All right, so here we have the lab that we've talked about a lot with the dialysis tubing, and this has a combination of starch and glucose in it, and then it's in a beaker of water. Now, over here, we have a pitcher of starch and a pitcher of glucose. You can see the difference in size. Remember that glucose is a monosaccharide, meaning it is one sugar molecule, and starch is a polysaccharide, meaning that it's many, many, many glucose molecules all put together. Okay, so it's a much bigger molecule. So the dialysis tubing is permeable to the glucose, which is smaller, but not to the starch. So starch cannot go through the membrane. So if you look at these beakers and what's going to happen, you have to think about two things. You have to think about the fact that glucose and water can get through the membrane, but starch isn't. And you also have to think about concentration gradients and how things are always tending to want to reach an equilibrium. So if you look at simple concentrations, okay, and we're looking, say, in the test or in the dialysis tubing, and compared to out of the dialysis tubing, is starch high or low? Inside the tubing, it is high. Outside, it is low. Okay. Inside, the glucose is high, and outside, the glucose is low. And then if you look at the water, water inside is low relatively compared to the water in the beaker, which is going to be in a higher concentration because there's no solute out there to take up space. So there's definitely a higher concentration of water outside. So what ends up happening is the things that can move will move. Okay, so that means that glucose is going to move out. Glucose is going to move from an area of high concentration to an area of low concentration. Okay, and those little red dots, those are the glucose. The big blue dots, it's the sugar or the starch, and that's not going to go anywhere because it cannot move past into the membrane or through the membrane. Now, water, what is water going to do? Water is going to go from where it's in higher concentration, which is outside, to inside. So water is going to go into the dialysis tubing. So over time, there's going to end up being water is going to go inside, and the glucose is going to go outside so that those reach an equilibrium. Okay, and starch is not going to move. So if you look at this graph over here, and you look at starch. We just said starch is moving. This is wanting us to look at time and the relevant amount of stuff in the bag. So disregarding the beaker, if you're just looking at what is happening inside the bag, the polysaccharide starch is not doing anything. There's some in there, so it's not down here at 0. It's kind of like here. So if we say this blue is the starch, okay, it stays the same all the way across. It doesn't change. So if we say this orange then is the glucose, what does the glucose do? We know it's high inside the bag, and then it gets lower, okay? So over time, it's gonna start dropping. It starts out higher than the starch, and it starts to decline over time because those are starting to move out of the cell. Then if you look at, I already used blue. Okay, I guess green is going to have to be water. If you look at water, water was in lower concentration in the bag, and then it ends up getting more of a concentration. So water would start down here and kind of raise up here. So this kind of shows you what is happening to each of those over the course of time inside that bag, based on things moving with their concentration gradient. Remember, this is all diffusion. It's happening in osmosis, and it's happening without any energy, and it is all happening because of the fact that the dialysis tubing is selectively permeable.